Hi, welcome to an introduction to data science in Julia. This lecture is part of the course An Introduction to Machine Learning in Julia. And in some of the past lectures, we have been looking at various basic things in Julia like installation, data structures, syntax, etc. In this particular module, which consists of more than one lecture, we'll be looking at various practices with respect to data science, like handling data, several data science libraries, loading and inspecting the data from CSV files, basic data analysis, data visualization, etc. So this lecture is the first lecture in that series. So we have divided the content of this lecture into a few different parts. First, we'll be talking a little bit about why Julia is so special for data science. And here we'll be seeing that Julia actually provides some high performance for big problem statements. The syntax is fairly easy to follow, similar to how it is for Python. And also Julia allows parallel computing. So if you have multiple cores in your CPU, you can basically divide a job into that many number of workers, and you can perform parallel computing. And Julia's inbuilt support for multi-dimensional arrays will also help us perform certain mathematical operations in a much more faster way. So we can explore some of these things through simple code, but at the end of the day, it's a great practice that you are learning to implement DS in Julia. One of the other things that we plan to do in this lecture is an overview of the key libraries, mainly DataFrames.jl, CSV.jl, and Query.jl. DataFrames.jl is basically like a way for data manipulation in tabular format. If you have worked in Python, you might be aware of pandas. So this is very similar to pandas, but better in some aspects. We'll be discussing some common use cases with a simple, easy to follow example. CSV.jl is very fast CSV file reading and writing package. It can handle large data sets. In the absence of CSV.jl, sometimes the loading of the data itself is half as slow. And Query.jl is for querying data, creating filters, aggregating, etc. So this is almost always used for complex data sets. In the loading and inspection of data, we'll be using the CSV.jl package primarily, but here we can explore different data handling practices. From a very basic perspective, if you are already familiar with this very well, you might as well skip this part. And we'll be looking at basic data analysis like filtering rows based on conditions, grouping data, counting unique values in a table, calculating aggregate values, etc. All of this will be very helpful when it comes to implementing an actual larger scale ML project. So in the upcoming modules, after these series of lectures in data science, we are entering into deep machine learning models that are traditional, and also deep learning models after that part of the course. However, in this part of the course, we'll be primarily focusing on dealing with data using Julia. So let us get into some coding. I have already shared in detail the instructions for installing Julia and setting up the REPL environment in Julia in the first lecture. If you have not followed that, if you don't have Julia installed on your computer, I will share it right here in the description. But in today's lecture, we'll start from pretty much from scratch by installing, adding certain packages, opening a fresh notebook in Jupyter Notebook, etc. So you have to have Julia installed and Jupyter Notebook also installed. And both of these I have covered in the lecture that I have mentioned. So I'll be sharing the link with you. So just go through that. It should not take you more than, let's say, 5 to 10 minutes. Maybe less than that. It's very easy. So let's go to terminal, open terminal. I'll just zoom this in a little bit so that you can read. And here I have already started a Julia REPL. REPL is basically read, evaluate, print, loop. It's a similar to terminal kind of interface, which allows you to run Julia code. But we'll start from terminal. So this is my MacBook terminal. And here I'm going to first type Julia. So that will open the Julia environment. So this is the Julia REPL, which just loaded. And firstly, we need to add certain packages. So let's say import pkg. So we are going to add packages. Oh, not import, using pkg. And then we will be adding pkg.add. We need to add CSV.jl. That was the one of the packages we described earlier. Then I think I have already added this package on my computer, so probably this will not install anything new. Okay, I guess it was not. The second thing is, if you already have the package this CSV package, CSV.jl package installed, it will not install anything new. But otherwise, you can expect this installation to take some time, like 1 to 2 minutes perhaps. It depends on the size of the package. And usually what I have seen is, if I have multiple packages to install in Julia, I have to wait for some time. It's not like few seconds. It can take up to a minute or two. So let's wait until that is done, and we'll come back. Okay, so that is done. Now the other package to add is pkg.add. We have query. And we have one more package to add, that was pkg.add DataFrames. Not sure if the F should be capital. We'll see. Yeah, I think the F should be capital. So this should add the DataFrames package. So now we have the 3 packages that we will need for this project. Now what I'll do is, so now that we have the packages, let us open a new shell. So I just typed Command N for opening this new terminal, basically. And here I'll type Jupyter Notebook. So I think I have mentioned this sometime before in one of the earlier lectures. So although there are different ways in which we can run Julia, you can run Julia on the terminal, Julia REPL. You can use Visual Studio Code as the IDE. You could use Pluto Notebooks as the IDE, but I prefer to use Jupyter Notebook at the moment, and that I'll be following that throughout this module as well as the course. So let's go ahead with that. Once you open Jupyter Notebook, click File, New, Julia file. This should open a new Julia file in Jupyter Notebook. And after this is done, actually, it's better to open, Jupyter Lab. So let me perhaps go back, close this file, open Jupyter Lab. And in the Jupyter Lab, I can start a blank .jl file. So this is my default folder. And here I can start one new Julia 1.11.1 notebook. And I would rename this as, so here it should be, maybe instead of IPy notebook, this is Julia notebook, right? So I don't think we need to add the extension, but let's name this as DS in Julia part 1. And now I can open the notebook right here in Jupyter Lab, or I can open the notebook separately by clicking this notebook. I guess not here, it's simply downloading, but this is, I guess it's fine to open it here. And here to check if the code is working, whether the notebook is working, just type something and see if you are getting the output. So 2 plus 2, 4. So we are getting the output. So the first thing is, I had mentioned in the introduction part of this lecture about some of the features of Julia. We can test some of those, like how easy it is to run code or even define the syntax in Julia. So let's check some examples. So maybe we can define a for loop for I in 1 to 100. Maybe outside this for loop, we can define count equal to 0, count equal to count plus 1. And at the end of all of this, I think we need an end statement, and we can print count, right? And one more thing we can do is, there is something called time, counting the time. So we can calculate the time it takes for Julia to implement this. But without that itself, just look at the syntax here. It's fairly straightforward. It's exactly like how you would write in Python. I hope I haven't made any syntax error here. Yeah, there is no issue here. If you were writing this in a Pluto notebook, you will have to start by writing a begin statement here and then put this with an indentation and then end statement. You have to write multiple lines of code in begin and end block, but that is not needed here because we are writing this in the Jupyter notebook. So now, this is working. So we can calculate the time taken for running this. It took only 0.00002 seconds. This is very, very fast. What if we increase this? Time will increase. I have added a few more zeros. So see, this is like, these are calculations that can be performed very, very fast in Julia. I guess first of all, the print value is also correct because we are adding 1 each time, and the count should be same as whatever is the maximum value here. We can also compare the results that we have here with Python, but it's okay. Let's not go into that. Maybe we can try that. So let me start a new kernel file, new notebook. New Python file. Oh, I should probably open Jupyter Lab, and so let's just remember the numbers, right? So here to go from 1 to this much, we took 0.43823 seconds. Let's see how is this in Python. So we'll start a Python 3 kernel, copy this, paste it here. I'm not sure if this is the way to count the time, but let's int. I think we have to define integer. I'm not sure. Let's run it without that first, and then we'll figure out. Okay, I can see that it's already taking time. Currently, it's showing it's busy and it's taking time. Print time taken to run the for loop in Python. Okay, we can do something like this. Yeah, at the moment, the Python is not working, or rather it's running very slow, exceptionally slow, in fact. Here you can see, maybe I should kill this notebook. Yeah, the Python code was slowing down my system by a lot. So I just killed that particular script. But what I'll do is let's open Jupyter Lab once again. And here, I hope this is a proof that Python is running much slower, but we'll see. So one of the claims that Julia makes is they can be as intuitive as Python in terms of syntax, but as fast as C or C++. So here, let me paste this code. So we are importing time module, and then we are running from, let's say, count equal to 0, then count equal to count plus 1, and yeah, so time taken is end time minus start time. So we are running only 1000 like 1000 iterations. So it took 0.00. What if it's 10,000? This is 100,000. This is 1 million, 0.16 seconds. So 1 million, doing a addition from 1 to 1 million, 0 to 1 million minus 1 took 0.1637 seconds. For Julia, it was 0.07 seconds. So I would say Julia is 2x faster, more than 2x faster for running the same piece of code. What if this is 10 million? Then this will be even more slow. Okay, so when this is 10 million, Python is taking 1.5 seconds, 1.57 seconds. And if this is 10 million, Julia takes 0.86 seconds. So you can pretty much see that Julia is taking only half as much time as, or close to half as much time as what Python is taking. It's also because of the superior way in which Julia handles some of this data. So I just wanted you to see this. This is one of the things that we discussed in the beginning part of this lecture. We can also try another example with matrix multiplication. So in Julia, let's use this. So here we are using a package called linear algebra, and we are multiplying two matrices A and B, and the result of that matrix is saved in C. And here we are printing the time. So this one took 1.85 seconds to print. Now let us do this in Python. So in Python, define random matrix. Two random matrices in Python. We could use ChatGPT also for this, but I think here itself you will get the result. Okay, so let's see. I'm copying this code, and rows, instead of, we can have 1000 rows and 1000 columns for all the matrices. And here we are defining it to be random. Then we are multiplying the matrices here. And what we need is also time. So start time and end time. I don't want to print the matrix. I'll just print the time taken. So let's see how much time this takes. Oh, 0.17. So, and here it was, but I'm not sure if it's, I don't think we're doing the element wise dot product. Let's see. We could also try. So here what I did is, for matrix multiplication, we should not be doing dot product, element wise dot product, because that's what we had before we had something like this. But then instead of using np dot dot, let's use this symbol at. So this should do matrix multiplication, and then it's taking 0.08 seconds. And what I can do is also multiply this random values by 1000 so that the numbers themselves are increasing. Okay, now this is taking 0.12 seconds to do the math. Not very slow. It's in fact quite good. Julia, on the other hand, it's taking 0.04 seconds, is it? Oh wow, this is much faster. I don't know why it was showing something different last time. So it's 0.2 now. It depends on, I think it's a bit random, right? So 0.02, 0.04, 0.03, 0.26, 0.13. So in general, I think Julia is on an average faster than Python in this particular matrix multiplication example. So here it's generally taking 0.03, 0.04 seconds. Here on the other hand, it's taking 0.07, 0.08, around that. Here also, I can kind of see that factor of 2, Julia running twice as fast as Python. But anyways, I hope this is not to prove a point. This is just to show the superior abilities that Julia may have in several applications. Of course, I don't want to deny that Python might be really good for many other applications, which Julia cannot handle that well. But I just wanted to show the power of Julia, at least with these two small examples. You can run this yourself, and you can see this effect. All right, now let's get into some of the aspects about data itself. We already saw an overview of different packages provided by Julia for data handling, like CSV.jl, Query.jl, DataFrames.jl, etc. So now what we'll be doing is, let's import a data. In any machine learning data science project, the first thing that we do is, wherever we have the data stored, we import that into our notebook. If you're working on Google Colab or Kaggle or Jupyter Notebook, you have to do that importing. So here what we can do is, let's first create a simple data set which serves as the sort of dummy data set for our code. So let's create that. So this can be similar to the Titanic data set. So I'm going to name this notebook, this Google Sheets, as Titanic data. And here we have the following fields. So first is name, age, gender, then last one is survived. So this is like the data set, a simplified version of Titanic data set. So let's say there is a person named John Smith, age 42, gender male, did not survive. Let's say this is false. The next person, Catherine B, age is 25, female, survived, true. Then maybe Sylvia, 39, female, survived. And then Jacob Adams, whose age is 12, male, survived, true. So let's say this is the data set. Now what we want to do is, if I download this as a CSV file, I want to load this onto my my Jupyter notebook. So let's see how to do that. So firstly, let's download this as CSV, comma separated values. And here, instead of untitled, you can say uploading data, not IPNV. Okay, so the data has been uploaded. Now what we have to do is, whatever we have downloaded, we need to, so using CSV, that is one package, and data frames, that is the other package, we have to import. Basically, we are loading the set onto a data frame, right? So df equal to csv.load, and then we have to provide the, I think I'll have to do like this, downloads slash .csv. I'm not sure if this will work. I'm pretty sure there should be some error in this code. Okay, load is not, yeah, okay. It's csv.read. And then what else? I'm not sure if this path is something that is not a valid file. So what about this? This is also not a valid file, which means what I have to do is somehow bring the downloaded CSV file from here to the other folder. Yeah, so Titanic 2 minutes ago. So I just need to cut and paste it here. Okay. So now hopefully if I just do Titanic, not a valid file. Titanic, okay, D should be small letter, I guess. And if we need to get the path, copy path. Okay, sheet1.csv. Okay, fine. So this hopefully loads the data frame. Now the problem is find. Okay, now it worked. So basically the problem was I had an extra S here. So if it was like this for me. So you don't need data frames here, just data frame is enough. And now the data has been loaded. So this is the data frame with the names of these people. So we have basically loaded the data set from where we had the data set in an Excel sheet or rather CSV file. You could have found this data from Kaggle, you could have found it from elsewhere, but ultimately you need the data here in this environment, in this Jupyter Notebook environment. So we have successfully loaded the data. So this is a very basic example of how to load data. Now let's see a few other actions. Let's say we want to print only the first few rows, let's say first two rows in the data frame. We can, I think, if we simply do this, first of df comma 2 means it prints only the first two rows. This prints only the first one row, first three rows, etc. So this is another operation. If you want to just display in Python, we sometimes display just the head of the data set, which is like 5 rows. Here also we are doing pretty much the same thing. Then we can ask to show the size of the data frame. So it's 4 by 4, and that's because it has 4 rows and 4 columns. 4 rows because there is name, age, 4 columns because there is name, age, gender, and survived. 4 rows because these are the data. These are the headers of the columns. So this is not counted as a data. So it's not 5 by 4, it's 4 by 4. All right, so that is size of df. Next is describe df, and this should provide like a summary. So here we can see that it has automatically added the row number 1, 2, 3, 4. Then here you can see some other things. So let's say the names, Catherine B, these are names, Catherine B, Sylvia, gender, female and male, and there is no mean value for gender because it's just a it's just gender. Then here survived has false and true. So minimum, min max, I don't think false and true min max makes any sense. Maybe because it's taking it as a binary. False is 0. I mean, Boolean, false is 0, true is 1. Maybe it's because of that. Then data type. So name is string. 15. I don't know what does it mean by 15. Maybe because the length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, it's not the length. Age. I think the minimum age here is 12. Maximum age is 42. Mean is somewhere in between. So equal to mean average equal to average of all of these, which is 29.5. And you can see that the mean is 29.5. Survived average is 0.75 because it's actually a true or false value. So survived, if the person did not survive, it's false means 0. Otherwise, it's true. So yeah, so that's pretty much it. You have int64, you have string, you have Boolean. That's all. So this is the description of the data set. We can also access specific columns in this data frame. So df dot, so we have a column named age. So df dot age should give us access to just that column. So age, it's a 4 element vector in 64. What about df dot name? It should be string 15, 4 element vector df dot survived. And the final one was df dot gender. So Boolean, string 15, string 1, and Boolean. So I guess the 15, let me search what is string 15. I'm not sure if it's the length of the sequence, the string with length 15. I'm not sure, but anyways, so this is the isolation of individual columns, which we can do very easily. We can isolate also groups of columns. So for example, df, we can isolate, let's say, age and gender. Or age and survived, something like this. So here what we are doing is we are isolating every single rows from these two columns. If we can play with this like and see when this is not working, right? So let's say what if we provide something like this? Then it if we do this, it should print the first. Okay, only the second one, I guess. And this won't work. So we are taking aged and survived as the column. And here df of 2, comma, this is what? Is this the second row? And okay, so this is basically, so df of 2, comma, colon is second row and all columns. And but if it is age, comma, survived, the syntax is not valid. So we can put like this. So now it becomes columns, because otherwise if this was absent, it does not make sense. So you add this. Now Julia knows that this is, we are talking about these two columns, but second row. And what if we need second and all the rows from second to fifth, or rather fourth? There are only 4 rows. Then we do this. And here, are we actually printing second to fifth, second to fourth, 25, 39, 12, right? 25, 39, 12. Yes, we are. And if you want to print all rows, just providing this is not enough, provide this. So this is how you isolate specific columns from all rows, or specific columns and specific rows, like this, right? What if we want to print the first 2 rows? Let's say first 2 rows from these 2 columns. So then all we need to do is like provide something like this. This will be first 2 rows. I don't think 0 is valid. It starts from 1. Yeah. So this will print first 2 rows. This will print all the rows. This will print first 3 rows, right? But only those specific columns. And if we only say only we want to print survived, it will be like this. Otherwise, I think we might be able to provide number. I don't know. Let's check. Yeah, so the first column is name. Second column was age, I think. So if we put 2, it will be age. Third column was gender. And fourth column was survived. Now, what if I want to print the columns in terms of numbers? Can we do this? For example, if I do 1, 4, what does it print? It prints the rows from 1 to 3, 1, 2, 3, and columns, first column and fourth column. First column was 4, last column, fourth column was survived. So here we can provide the header of the column or just the index of the column number. So we are printing first column and fourth column, and we are printing rows 1, 1, and 3. I mean 1, 2, 1 to 3. What else can we do? We can write like this 1, 2, 3. Then also we are specifying specific rows. If we provide just 1 and 3, it will print only the first row and third row. Although the row number here it is 1 and 2, actually it's printing the first and third, because first is John Smith, third is Sylvia. That's what this is doing here, right? So this is how you can basically fetch anything from the data frame once you have it loaded. Now it is time for us to perform some basic data analysis, right? So when we say basic data analysis, changing this itself and maybe printing the mean value, and doing some very, very basic operations that you will inevitably end up doing once you are into data science. So first, let us print the entire data frame. So this is our data frame. We have 4 rows, 4 columns about Titanic Survivor. This is the dummy data, of course. Actual Titanic Survivor data, if I remember correctly, it has 1,800 or something more than that. There were that many passengers. So there were, or a slightly more number of passengers, and that much was the size of the data set. Now let's define a filter. I want to filter all kids less than age 15 from this data, and which means only this Jacob Adams would be there, right? So df age filtered. So I'm trying to filter equal to df dot filter, I hope. And we are passing in the row such that row dot age is less than or equal to 15 in this data frame. I'm sure some syntax error is there. Filter is not found in data frame. Okay. Oh, about this. All right. Yeah. So this df thing was not required. So I had put something like this. I mean, yeah, of course, does not make sense because df, this is like a variable. So just put filter and the row. So basically what we are doing is we have a filter into which we are passing rows. Within the rows, and once the row is passed, we are checking for the column named age within the row such that the value of the column should be less than 15, because we are saying anyone with age less than 15 is a kid. And here it filters out. So this variable df age filtered is like a filtered row from the set of rows in this data frame such that the age of the person is less than or equal to 15, and there is only one person like that. If we put this, let's say less than 30, less than or equal to 30, it should contain Catherine B and Jacob Adams, right? So this is how that works. This is filtering of the data. Now there are two more things called grouping and combining. So in grouping, let's say group data equal to group by, we are passing the row such that actually we are just passing the data frame and we need gender. So let's say we do this grouping and then we can print how the group data looks like. Yeah, so here we are grouping the data set and it's forming actually two groups because there are two genders, and for that reason it's forming two groups. The group 1 consists of both males, John Smith and Jacob Adams. Group 2 consists of two females, Catherine and Sylvia. What if instead of gender we had put age? It should ideally form 4 groups because there are people from 4 different group data frame with 4 groups based on the key age. But why am I not able to see all the groups here? Because okay, so it's like there is a dot here. Basically there are 4 groups. Then name means also will be the same thing. Survived, if it is survived, there will be only 2 groups, false and true. There will be 3 in the true category and 1 in the false. See, so this is how we are grouping. So here we are grouping first based on gender. So we have 2 males and 2 females, and for that reason we have 2 groups. All right. The next thing is called combine operation. So in combine operation, we are finding some statistics about those individual groups. So why did we group this in the first place? Because after grouping, we want to find some characteristics of the group, right? Maybe we want to find the mean age. We want to find whether people survived most or not, things like that. So here we have to use a package called using the statistics package. So if you have not installed this, you will have to install add the package using the pkg.add in the terminal. But assuming that you have this, you just use statistics package and then that will help you use this mean. But basically in the variable called summarized data, we are taking the group data, but then finding the mean of the group. So after you run this, you will get that the group where gender is male has a mean age of 27. And is that true? Because the mean total is 54. There are 2 people, so it's 27. Here it is 39, 49, 59, 64. So this should be 32. and it is 32. So for females, the average age is 32. The males, it's 27 in this particular case. We could also do the same for survived. So the mean value of survived for men is group data survived. It was for men, it was false and true. So I guess false is 0, true is 1. So the average is 0.5 here. It's 1 for true, 1 for true. So the average is 1 itself. So for females, the survived is 1. And for males, the average value of survived is 0.5. So there was age, there was survived, and then I wonder if we add gender, something happens. Yeah, it does not make sense because it's a string. But I guess this is good enough. So this is what the combine function does. Now there is one more function called unique. So unique basically allows us to print how many different unique let's say characteristics are there in the data. So unique could be df.name. How many unique names are there in this particular data set? We have 4 unique names. All of these are different names. But if the names were similar, 2 of the names were similar, there will be only 3 unique names in that case. And what about unique of df dot, let's say, survived? Only 2 will be there because it's true or false. So because it's a 2-element Boolean vector. And what if it's dot gender? That also is true. It's only male or female. So this is the unique function. Next is sum and mean. So sum, let's say df dot age. So here it's the sum of the age, which should be equal to sum of all of this 118. So we should get 118 here. It is 118. And if it is mean of df dot age, it should be 29.5. We also have that. What about survived? Will it be because 3 people survived and 1 person did not? So this sum should be 3, I guess. Yeah, it is 3. So mean of survived will be 3 by 4, 0.75, right? Let's check. 0.75. That is correct. And age is fine. Gender, I don't think this will work because, yeah, it cannot be string. So those are the mean and sum functions. So we are learning how to manipulate the data. So we can add a new row. So let's define a variable called new row and name equal to Thomas, age equal to 55, then gender equal to male, and survived equal to true. So here the t should not be capital, it should be small t, right? And then we can do df, actually it's push like this. You have to put an exclamation. We are pushing this new row into the data frame, right? But we are getting an error here because yeah, this should be like a tuple. So we had discussed tuple briefly in one of the first lectures, but basically if it is in a square bracket, it is an array. If it's in a normal bracket, it's a tuple, and we are pushing that into the data frame, and then it should work. See now, so previously I had tried to push this name Alice twice. So that's the reason why it got pushed twice. And then you have Thomas here. So this is how you add a new row to a data frame. You can also pop from, I guess, we have to provide the row number. Is it? Let's check. So actually popping does not work. Popping as in, because this is a data frame. So what we can do instead is we can redefine the variable df with just the, maybe let's say first 6 rows, and then we can do something like this. This should hopefully make sure that the 7th row is removed. What is the 7th row? The 7th row was the person I added after Alice, which is Thomas. So here we are redefining the data frame df to be all the rows from row 1 to row 6, but we are taking all the columns. We can also, I guess, remove columns like this very easily. Let's say, but I don't want to do it right now. What if you wanted to remove the fifth row from this? How would you do that? Then we can use a function called not. So df equal to df of not 5. So not 5 means everything except 5. So what this should hopefully do after we run is the fifth row, Alice, this row will be removed. So now currently there are 6 rows. Previously there were 7. We removed the 7th. Now we are removing the 5th. And now the Alice should be removed. Yeah. Now since there were 2 Alice, it's a bit confusing, right? You are not sure if 5th or 6th got removed. So now let's say you want to remove Sylvia. Just run this. Change this to 3. Now Sylvia is removed. So this is how you can very easily remove rows from data frames. So I want to summarize this lecture because we are winding it up here. We looked at different packages in Julia which will allow you to handle data. So we created a dummy data set of Titanic survivors whose name, age, gender, and survived status was provided. Name was string, survived was Boolean, gender was a single, it was a string of single length, and age was integer. And we first downloaded this as a CSV file into our computer and we loaded it here. In the loading, what you have to be certain is that the path, you know the exact path to that file if you are loading it from your computer. After loading, we can display the data frame. Here data frame is defined using this data frames package, and the CSV.jl package is used for reading the CSV file. Then we looked at various ways in which we display the data frame. We could display the first 3 rows. We could display the size. We could describe the data set in terms of what its variable type is, what is the mean value, min, max, median, etc. Then we also saw that we could just isolate individual columns from the data frame. And so using that, we could isolate age, name, survived, etc. We also saw that we could just isolate, let's say you want certain rows and certain columns from the data frame. You can also do that very easy. And to index those particular rows and those particular columns, for rows, you have to provide the number of the row because row is defined by the number. For column, you just need to either provide the number, index, or the name of the header of the column. We saw how to display that. We also saw how to filter from the data frame and filter, and actually after the filtering is done, you can actually save that into a new data frame. And here the filtering was done such that we wanted to find all the people below the age of 15 or less than or equal to 30, and you could see the result. You also saw that grouping can be done to create multiple groups of data sets. So here, when we group it into gender, based on gender, there were originally 2 males and 2 females. So 2 groups were forming with 2 people in each. If you grouped it based on survived, then there were again 2 groups, but in one group there were 3 people, in the other group there was only 1 person. And we also saw that we could combine the group data, basically combine the group data with some group-wise statistics. So the group-wise statistics that we looked at here was age. That was one thing, the mean value of the age. We also looked at the mean value of the survived, because survived false means 0, true means 1. And if the average of true and false is 0.5, which does not carry any meaning, but that was the average. Then we also saw that we could display all the unique elements within a row. Then within a column, we saw that we can do sum, we can do mean, we can create a new row. So here we defined a new row as a tuple, which is why it's in a normal bracket, not in a square bracket. And we can this new row can be added very easily into the data frame by doing something like this. So df, let's say the new row was added in the following format. We use push. So what if we did push? We are pushing the new row to df. We could add this Thomas into the data frame, but the popping operation, which can directly pop out some of the values in an array, is not applicable in data frames, because here we have tuples. But what we can do is we can define the exact same data frame with the exact same name. So here into df, another value of df is assigned, such that here in this particular case, for example, the third row is removed. So for example, here now the third row is Jacob Adams. So if I run this code, Jacob Adams will be removed from the data frame. So let's see that. See, Jacob Adams is removed. Only John Smith, Catherine, Alice, and Thomas are remaining. So this lays a strong foundation for the basics of operating or dealing with data in Julia. And this will be extremely beneficial for you as you move forward in this module. So in the upcoming modules, we'll be performing a few different operations of data cleanup, for example, data visualization, etc., which I'm so excited about because I am personally a big fan of visualizing data in a very easy to communicate manner. And without these beautiful visualizations, I don't think humans would be as efficient at communicating complex data sets. And I want to walk you through some of the packages which allow you to visualize data in brilliant format in Julia. So we'll be exploring all of that in the next lecture. But I want to take a moment to kind of congratulate you for reaching this far in the course. You are really at the cusp of mastering the syntax and basics in Julia, and we are on to something a bit more complex in the upcoming lectures. And at the end of the day, we'll be using all of this knowledge for building machine learning and deep learning models for implementing on actual problem statements. So take care. We will meet again in the next lecture. Thank you so much and see you soon. Bye.